This week's topic in our class is on topology, or the spatial relationship between and among features in a GIS. Topology is an overreaching concept in GIS, and it helps us to ensure that our data are valid and appropriately spatially correct, as well as it helps facilitate performing location or spatial based analyses of data. So this first video, we're going to look at how data are organized, particularly how features are modeled as coincident when they share the same location or are connected in the same location. We'll also see some editing methods that'll help you to ensure that your features are spatially correct and coincident in different places. And we'll talk a little bit about the vertical integrity of data. Now, there's several tools in ArcGIS that help us to manage topologically or spatially related features. But for this first part of the video, we're just going to look at some kind of basic editing tips and tricks on how to ensure that your data are built in a topologically correct way. So I'm working with the Editing and Topology ArcGIS Pro project. I'd like everyone to follow along with this video. So if you have not downloaded and opened the Editing and Topology ArcGIS Pro project, please pause the video now and do that. As you follow along with me, feel free to pause the video at any time, back it up, and try to keep up and practice some of the things that you'll see me doing in this video. So we've got some bookmarks in this ArcGIS Pro project. I'm on the Editing and Topology map here, and I'm going to go to this split polygon tracing a feature bookmark, and it zooms in to this area. So in this layer, in this map, the primary yellow layer with orange boundaries you see is the Emergency Management Services layer. So these are the zones in Buncombe County that the Emergency Management Services folks use to keep up with services they provide to people. In addition, we've got a fire stations layer here as a point layer, and we also have the major or primary roads layer for Buncombe County. So the first thing I want to show you is how polygons are modeled in geodatabase feature classes as well as shapefiles, as far as how their adjacent boundaries between adjacent polygons are modeled. So I'm going to go over here and make sure everything's selectable. So I should be able to select everything in this map. Go back to list by drawing order. And what I'd like to do is to select this polygon. I can start by just identifying it as well. And you can see that that's a reasonably large polygon, and this road kind of cuts down in through the middle of it. This road is New Leicester Highway. If I identify that road, you'll see it's New Leicester Highway. And this EMS polygon is for station E6. We don't want to get caught up in what all these numbers necessarily mean. We didn't build the data, and essentially they're identifiers for the zones. But so what I want to show you is how these lines between adjacent polygons, say this polygon E6C and this polygon, E6A, how the lines between these kind of adjacent polygons are actually modeled in the GIS data. So in order to do that, I'm going to go to my Edit tab here, and I'm going to go on and select this polygon, and you'll see the outline of the polygon selected. Notice this boundary here in between this polygon and this polygon. If I select this polygon, you'll see that line is also selected, which tells you that line in between these two adjacent polygons is stored as part of the definition of each of the individual polygons. If I zoom in a little bit and I click on Edit Vertices here, you'll see all of the vertices that make up this polygon. Now, for this data to be built in a topologically correct way, all of these vertices should be part of the line that defines this polygon too. And so if you just look here, you can see there's 1, 2, 3, 4, 5, 6, 7. You can kind of see these vertices going up this way. So if I click on this polygon, you'll see it's made of the exact same vertices. Each one of these vertices, this vertex, this part of the definition of this polygon, is coincident with the vertex that defines this polygon. They're essentially in the same place. Refer back to our PowerPoint from this week on feature coincidence to better understand what we're talking about with coincidence. Essentially, it means that they're in the same location, or technically within what's called the cluster tolerance of those features. So during a regular edit session, let's just say that this polygon boundary for this selected area here, let's just say we wanted to adjust it. And so we drag this vertex down here. Okay, so now you can see that created a gap between these two polygons. I can go to edit this adjacent polygon, and I can grab that vertex and I can drag it down until it snaps, and that keeps that data topologically correct, because these two, I moved one vertex from one polygon and one vertex from another polygon and made sure that those vertices remained coincident by snapping them together. The point is, it took two edit processes. I had to move one vertex and then another vertex to make it work. So you want to ensure that you maintain that kind of coincidence between features when you edit them. Now we're going to see soon the map topology tool that is under here that allows us to do that very thing, to edit coincident features and maintain their coincidence without actually performing two separate edits or more. So we'll see that when we come back soon. But what I want to do first is show you a few other editing processes or editing tips. And so I just undid those two edits, and I'm going to clear my selection and zoom out a little bit here. So for this scenario, let's say that we want to split this polygon based on the fact that we're a GIS technician and our EMS manager, coordinator, boss came to us and said, we need to split zone the EMS. I don't want that turned on. I really just want the feature selected. So I'm gonna go to just click on the modify tool and make sure it's selected. So if I identify this again, or I can look at the attributes by clicking the attributes button here. This is EMS area geo proximity E6A. Okay. Now imagine your boss came to you and said, we have had such a large population increase in this area that we want to make 2 EMS zones by splitting E6 geoproximity area E6A. We want to split it along New Leicester Highway, and we're going to have the area below be geoproximity area E6A2. So we've seen the split tool this semester, and it's a handy tool for splitting polygons. And the split tool, actually, if I split this polygon just by doing that and double clicking, I get 2 polygons. And the split tool actually builds coincidence in between these polygons. So the vertices that make up this line are part of the definition of this polygon as well as this one. Now I'm going to undo that, edit. Okay. Now, if you remember, we saw how the split tool allowed you to split by feature. So it'd be nice if we could just split this polygon by this line. In this case, this line that defines New Leicester Highway is made up of a bunch of line segments. So it'd be kind of hard to use that line to split without selecting them all. And it's just kind of an unruly process when you've got so many road segments. You could merge those road segments together. However, we typically have a lot of road segments because we manage and model address ranges along a road with road segments. So that selected road segment there, you can imagine it is the 400 block. So the address ranges are 400 to 498 on one side and 401 to 499 on the other side. So typically you don't want to merge roads together because you lose the address ranges. So using the split by features, we could get all those selected. But again, it's just not super easy with this particular data set. It's nice that we have that tool, but I want to show you another method of doing this, and this is kind of, I guess we could call it the old school way, but it'll help you to better understand how we split features and how we can use other features and maintain this vertical integrity between our data. So oftentimes what you see people do is they come in to split this polygon. They're told they want to split it by this road, and they have snapping turned on, so they just come down here and they kind of just come along and try to do as good as they can, snapping along the way. Okay, and zoomed out at this scale, this doesn't look bad. Looks okay. If I double click, there's that data. That polygon split into 2 polygons. But if you zoom in, you'll see that we didn't really build good vertical integrity between the data. Out there in the real world, New Leicester Highway defines the demarcation line between these 2 EMS areas. And if you see this little gap in here, this EMS layer does not go across the road to here. It is at the road. So I'm going to undo that edit too and show you that when you go to split and you have this little toolbar that pops up, by default you start drawing lines. You can enforce angles with the lines you draw. You could split it with a curve, and you can flip between these tools as you go. Or you could trace a feature. And so in this case, if we come up here and you can, I oftentimes just start outside of the polygon. You can snap to the polygon boundary that you are going to split, but I'm just going to start outside, and the trace tool, you can see it kind of starts following up this line. Now I just clicked one time to start it, and I started slowly moving my mouse up, and you can see it starts following this line. I'm going to press my middle mouse button down and pan over and let it come all the way up to here, and when I get outside of the polygon, I'm going to double click, and it splits the polygon in two pieces based on that line. So now I'm going to clear my selection, and if I turn the roads layer off, since this EMS layer is below it, you'll see the boundary and the road are the exact same. They are coincident, and that's building this vertical integrity between our data layers into our data set. So, of course, if I select this polygon and look at the attributes, you'll remember that that polygon was E6A. And I said I'm going to name this new polygon. So I need to select it. I'm going to name this new polygon E6A2. So if I click in here, E6A2, and I'm going to put a 2 after E6 there too, and I'm just making that up as I go, but you'd want to update the attribute values as well while you go. So I'll clear my selection, and I didn't commit those attributes by applying, so I want to go on and commit those attribute values. And I could come in to this layer, to my EMS layer, and I could label it based on, and maybe I should have done this before so you could see the you would have seen the new label pop up immediately, but so I'm labeling it based on that geoproximity field, and I'll click label here, and so this is my new polygon that got created just now using that new method. Okay. All right, so that's one example, one method used tracing one feature to modify another feature. So let's go back to our map tab, and in our bookmarks, let's go to our align polygons. So the align polygons bookmark zooms you up to the northern part, northeastern part of Buncombe County, and this is a Forest Service boundary. The Forest Service boundary here is the Coleman boundary area, also called Big Ivy often. It's out past Barnardsville. And so what I want to look at here is the boundary of it compared to the boundary of our EMS layers. You can see they don't line up well. So in this example, the Forest Service boundary came from the Forest Service. The EMS layer came from the county. So this kind of thing you see a lot in GIS data, especially when they come from different sources. So we are going to modify the Forest Service boundary to make it match our county data. Now, there's not enough time and money in the world to fix every data set that you come across like this. Depending on your project, you may or may not need to fix data like this. You should assess if you think it's going to, this data discrepancy, you should assess if you think it's going to cause problems with some kind of analysis you're going to do, or if the scale you're mapping at it just doesn't look good. You know, if you're zooming at a small scale, large area, and you're really far out, you may not even notice that difference. But if you're mapping zoomed in, you would notice that difference. So again, you're not going to fix every data set you ever come across like this, but the main point is that you know how to, and that you know when you build data, you should strive to make the data be vertically integrated and spatially correct between the layers. So the first thing that I'm going to show you how to do is we'll go back to our Edit tab, and I'm going to, again, we want to move this Forest Service boundary to our EMS boundary. And I made the Forest Service boundary a little bit transparent so that you can see in some places it goes past the county boundary, in some places it doesn't reach the county boundary. So you can modify this feature by editing a vertex. So you could grab individual vertexes and you can move them out to try and snap them. Okay, so there, that's a vertex, so I could move that one and snap to it. So you could individually move the stuff. That is certainly not the best way. You could also fix them by, and let's turn off edit vertices. I'll go back to modify. You could also go to modify the feature and reshape it. Now reshaping it allows you to reshape it to any shape you want, really. If I double click, snapping to the edge or inside, it reshapes it. Now, of course, I don't want to reshape it like that, and I'll undo that. So what I see a lot of students doing is they come in and they go down and they try and hit every vertex as they go to reshape it to make it match this line. And you could certainly do that, but a better way would be to use this modify reshape tool and trace the line again. So I'm going to undo that again. I'm going to reshape, but this time I'm going to trace. And so I'm going to start there, and see, I click one time, it starts tracing down that line. Whoa, the trace tool kind of jumps around. It can be a little tough to use sometimes. And let's just see, let's just see how this does. Okay, if I double click, all right, so it reshaped that feature and traced it along that other feature. All right, so that's a good method for making polygon boundaries and other features line up. Now, I'm going to zoom out a little bit, and in the modify pane, I'm going to go back one, and what I want to show you here is a whole another tool that's kind of a newer tool, and it helps this process a lot. So this tool is called Align Features. And so if you'll click on the Align Features tool, still with your Forest Service boundary selected, what this tool does is it aligns features of one feature class to another feature class based on a tolerance. And so you can have different things happen when you use this tool. Like you can have it fit shapes to path, which we're going to draw a path and have it fit shapes to path. You can make sure that it preserves shapes outside of the alignment area so that it doesn't get rid of them. I have not used the snap line ends to path before, but you can control if the tolerance area is on the left or the right side and how it works with the ending of the lines. So what we're going to do, I did a little testing, is we're going to put 1,000 here in the tolerance. We're going to leave all these defaults, and we're going to draw the alignment path. Okay, and I'm going to pan down here just a little bit, and let's say I want to move this over and then align down this way. So I'm going to click there, and it's kind of like the trace tool. I clicked one time and I start moving down along this path, and it starts tracing it. Now it's not kind of like the trace tool, it's because I've got the trace tool clicked there. So I'm going to escape out of that, and I'm going to draw my alignment path. And this time I'm just going to click my straight line tool just so we can see that work. And in this case, you really want it to trace. You could start there, click there, and notice it starts to build this 1,000-foot tolerance. Now, I actually want to just go on and trace. I think that'd be a better method. So I can flip to trace right here in the middle of this thing, and actually, in this case, I don't really even need to trace because I don't even need to hit the lines, because as long as those two fit, as long as that tolerance is catching both what we're going to move and what we want to move it to, it should work. Okay, and so I'll go to there and I'll stop, and I'm just going to click a line. All right, and so you see that it didn't really work very well. Okay, so not tracing was not really the best method. So I'm going to undo that edit, and we're going to get back here to this alignment, and I'm going to zoom in a little bit, and I'm going to start with my line tool, and I'm going to click one time, snap into that edge, and then I'm going to trace. Okay, so let's just click one time and let the trace start, and you see it running down. I'm going to click one time just so I can pan, and I'm still on the trace tool, but you can click it to get it to if it keeps like freaking out and going off the wrong direction, you can click to kind of stop it there and then restart it. That kind of can help if it keeps jumping off in the wrong direction like that. So I'm going to click there, and I'm just going to double click to finish. Okay, so let's see how this alignment path works now. If I click a line, it aligned it up perfectly. So that align tool, align features tool, is a pretty nice tool for fixing this kind of thing. Now, again, these tools are not topology specific exactly. These tools and methods, the align features is kind of that. But some of these methods I've been showing you and things we've been talking about are essentially ways to ensure that you create data that has coincident features even within feature classes and beyond between feature classes, within feature classes and between them. So I want to show another kind of topology related tool that helps us to again build data in a topologically correct way. So let's just say that you've been asked to create a polygon in the Forest Service layer that goes through here. Somehow or another, the Forest Service gains some land in here, and you want to add a polygon adjacent to this polygon here. So I want to, on the Edit tab, I want to go to Create. Now, if you just use the regular Create tool, now I need to, in my Create Features pane, I need to click on the appropriate editing template here, and I've got all these tools that I can create polygons on my target layer. So that's the regular polygon tool. So if I need to create a polygon that's adjacent, I'm going to show you how I've seen people do it. They just kind of, try to do their best to make things vertically correct between layers, but they don't do a very good job. And I'm just going to click a few times. Now, how about here to using the regular polygon tool, you have to recreate this area between the two. You have to recreate that adjacent coincident line work, and it's really hard to do just by clicking. You'll see I missed vertices all on the way. So there is a tool specifically made for adding adjacent polygons. It's called the autocomplete tool. So I'm going to undo that edit. And first thing I'm going to do is select that polygon and look at the vertices to show you how many there are along its path here. So too many to recreate by hand. So I'm going to go back and clear the selection. And this time what I'm going to do is I'm going to create a new feature. And instead of using the polygon, I'm going to autocomplete polygon. So this autocomplete polygon tool creates an adjoining polygon using an existing polygon in the same layer to complete the coincident edges. So I'm going to start by snapping to the edge there, and I'm just going to go on and trace my county boundary because it needs to follow that county boundary anyway. Okay, I'm going to click here to stop, and then I'm going to grab this tool, and let's just say the polygon comes down this way. Then I'm going to change to my curve tool. This is really just showing you that you can switch between tools as you draw stuff. Okay, and then I'm going to go back to this tool, and I'm going to, I could trace up that road, but I think I'll just double click here and snap to that vertex in the National Forest layer, and it's going to recreate this line in between. Right now the polygons are kind of overlapping, but it's going to, when I double click, recreate that line. Okay, so the autocomplete tool is how you add adjacent polygons, ensuring that the polygons have coincident edges in between the two adjacent polygons. Now you might be seeing this area up here and think, well gosh, shouldn't we make that area match the county line there too? Well, that's a big gap, and I don't think it's Forest Service land. As big as it is, it doesn't look like it's just discrepancies in the two data sets. It's probably private land not owned by the Forest Service. You could download the parcel layer from Buncombe County and drop it in there and identify it and see exactly who owns that data. I'm going to delete that polygon just by clicking delete. I don't really need to save that. Hopefully you did some of this work as you went along as well. And you can stop the video and practice all you want. You could split this polygon in half using this line, this road that goes up into the forest. So before we move on, I want to show you two other quick things that we're going to come back to in a topology, a geodatabase topology video. If I go to my map tab and my bookmarks, sometimes errors in the data are so small that they're hard to see. So I just went to my polygon overlap bookmark, and if I select this polygon, oh, you'll see it, it looks like it goes under this polygon, and in fact it does. This polygon here is on top, and this one's actually under it, and so they don't have a coincident line there. There's an overlap in the polygons. So those kind of errors are really hard to find. So we talked about map topology. Map topology works during an edit session, and we're about to see it in just a minute. It helps us to manage those kind of coincident features during an edit session. But how about finding errors like that? They can be very hard to find. Let's look at one other example. Here's a polygon gap. So you can see, I'll clear my selection, there's a gap between these two polygons. But if you're zoomed out, it's very difficult to see that gap. So how do you find these kind of errors in your data? That's what a geodatabase topology allows you to do. It allows you to set up rules and then check your data against those rules. Okay, so for now, let's go look at, I'm going to zoom out a little bit on that map, and let's go to our map topology tab to expose the map topology map. This map has the sewer lines from the Metropolitan Sewer District and some sewer structures. The sewer structures are essentially manholes. And we want to go in here and look at how coincidence not only applies within a feature class when you're talking about adjacent polygons and the lines that define the adjacency between those two, but you also have coincidence between features in different feature classes. You'll see this is a gray, the check box is a little light there. That means that has a scale dependency. It's not going to turn on until I zoom in to lower than 1 to 15,000, I think is what I set it to. So see, I'm at 1 to 16,000 now, and if I go in one more time, you'll see they turn on. Okay? So I have a bookmark built for this. So let's zoom to the map topology two feature classes bookmark. And here we are. So with data like this, if we zoom in here on Gaston Street a little bit more, thinking about the coincidence between features, a sewer line out there in the real world goes to a manhole. So this manhole here should be connected to this sewer line just like it is out there in the real world. Without that connectivity, you can't do things like model flow through a utility network in the GIS. Okay, so that connectivity is very important for things like spatial analysis. You also want those things connected out there in the real world, because if your sewer line doesn't connect to the manhole in front of your house, the sewer pours out into the ground. So if I select this line and go to my Edit tab, and I click on the vertices, the end point of that line, and then I'm going to select my point still with Edit Vertices on my manhole. That manhole was snapped to the end of the line using the snapping tools. So the manhole is coincident with the end of that line. All right. Now, in a regular edit session, if I wanted to move that manhole, I would have to also move the connected sewer lines. And it's not that hard to do for one or two edits. Let's just watch how it would work. So I'm going to select, I don't want to be on Edit Vertices. I can go to my Modify tool here, and I'm going to select that manhole. Let's click our Select button first. I'm going to select the manhole, and I'm going to move it over here. Let's just say the location of that manhole was low in the topography of the area, and it kept having water infiltrate it during storms. So they wanted to move it. So I'm going to go grab my Move tool, and I'm going to move that manhole to here. And then if I click, it's not selected anymore, and you see it move over there. Now if I select this line and I go to Edit Vertices, I can grab that vertex and snap it to it. And that snapping, I'm going to click this one as well, and I'm going to move it. That snapping ensures that those features remain coincident. Okay? So that's easy enough to do, but if you have a lot of edits to do, it helps to use map topology, which when you're using a map topology, essentially what it does is it builds this thing called a topology cache in memory. It determines all features that are coincident or within the cluster tolerance, and if you move one, it moves any coincident features with it. So I'm going to undo those edits. Undo, undo, undo. I'm going to turn on my map topology. Now under this drop down, if you have a geodatabase topology, you'll see it, and we'll see that coming up. Now if we look at our map topology options here, you'll see my cluster tolerance is a really small number. It's the default cluster tolerance, which is almost always okay to use. You could put in your own tolerance. We rarely do that. If you put in one that's not very big, it starts, or that is big, it starts collapsing features on each other. If it's too small, it doesn't do anything. So I'm gonna go just click Map Topology. And let's look here. Maintain feature contiguity when editing. Okay. Enable Map Topology. Just trying to get that. Enable Map Topology to edit topological edges and nodes for all layers in the map using tools in the Modify Features pane. You can also enable geodatabase topology here. So let's just see what map topology does. If map topology is enabled while you're editing, and it computes coincident features. So I don't want to be editing vertices. I want to move that. So I'm essentially modifying. I've selected the feature and I want to move it. And because I have a map topology enabled, you'll see in the Modify Features pane, you've got features and edges. So remember, edges are essentially the line work. It's the underlying topology graph, they call it. And so I don't want to move the edge in this case. I want to move this feature. Since I'm in a map topology and since the ends of these lines are within the cluster tolerance, therefore coincident with that manhole, if I move the manhole and then I have to click here to make it move, it moves coincident features with it. Okay, so map topology, a simple topology. It's available at all licenses of ArcGIS, and it essentially helps you to maintain coincidence between features while editing. So I'm going to undo that edit. You can leave the edit. Go and practice with some of these other features to practice with map topology during an edit session. Now, how about manholes that aren't on the end of a line? All manholes should be on the end of a line, and so how would we find all those? Again, we can make a geodatabase topology rule to go through a data set that has thousands of manholes in it and show us all the ones that aren't properly connected to the endpoint of a line using a rule. Again, we'll see that coming up in the next video. What I want to do now, before we do anything else, is show you one more example of map topology. So in this case, we're going to look at how it can be used to manage these lines in between adjacent polygons within a feature class. So notice on this map, topology is not enabled. And so I'm going to go in and I'm going to turn on map topology. My Modify Features pane is still open. I'm going to go back because it was open from the earlier, from the map topology map. And so if I say that I want to modify a feature and I want to move some vertices, I want to edit some vertices, okay? But I want the vertices to move, the coincident vertices to move with each other. Notice I have my features and edges options here again. And this time I'm going to click edges and it automatically shows me all the edges in between polygons. If I go to select an edge, I click this, I go to select an edge with edit vertices enabled here. Notice I've got this purple selection color that tells you you're working with an edge. And in this case, I can move a vertex. And if you remember, during our previous simple editing example, you'd have to move the next the vertex from the adjacent polygon to move them both. In this case, I move it and then I click right here and it moves them both. Okay? So again, I made a selection with edges enabled and click out of it, and it's moving both of the it's moving the lines with all the adjacent vertices or coincident vertices. So I'm going to zoom out a little bit and just show you what would happen. What if you wanted to move, let's say, this whole polygon here down some? Well, if I go to Features and I select Features, you see it doesn't really do that. But I can go here to Edges again, and I can select not with Edit Vertices on. I want to go to Modify, get rid of Edit Vertices. I want to move. So I went to Move, and now I'm going to Edges. And if I grab this edge and just move it, see how in the bottom left there, it's kind of just stretching this whole thing. And so it's going to, I'm going to click here, and you see it moves the whole thing, and it like stretched these, some of these coincident areas out. I'm going to undo that edit. That's not something that you want to do as often, but I did want to just show you you can move a whole polygon. Whoops, I've got trace on there. I didn't mean to do that. Okay. All right, so that's it for this video demonstration of some basic editing tasks, the editing environment in ArcGIS Pro, trying to ensure that you've got this vertical integrity built between multiple layers in your data, and that you're always editing to manage coincidence, whether you're working between layers or within a single feature class. So we saw a bunch of tools to work with, and we also saw how map topology, available at all licenses of ArcGIS, can also help with this and facilitate the process a little bit. So next, I'm going to put up a video of working with the second type of topology we can use in ArcGIS called geodatabase topology, and we'll also be using this ArcGIS Pro project for that. So look for that video as well. Thanks for listening.